Hi, Mr. Eaton here, and we're going to use trigonometry to find the side lengths when we do not know what the denominator is. Alright, so just a bit of quick linear equation revision, so solving for x when the denominator is not known. Alright, so in this equation we have cos 35 equals 2 over the pronumeral x, so the x is the unknown. We've got to figure out what x is. So remembering what we do when we solve these types of equations, we need to keep them in balance. So what we do on the left hand side, we need to do on the right hand side. First thing I'm going to do is try and get rid of my x over here. So I'm going to multiply by x, and therefore I need to multiply by x on this side. So I'm going to have x cos of 35 equals 2. Right, well now what I need to do is I need to get x by itself, but x here is multiplied by the cos of 35. So the opposite of multiplication is going to be division. So what I do on the left hand side, I need to do on the right hand side. So I'll do this in two steps. So I'm going to go to cos of 35 divided by the cos of 35 degrees equals 2 over the cos of 35. And as we know, cos of 35 cancels with that cos of 35 because we can treat them as fractions. So therefore we will have x is equal to 2 cos of 35, and when I put into my calculator 2 divided by cos of 35, I end up with the value of 2.44. Therefore x is equal to 2.44. Alright, well, I need you to find the side length of the pronumeral x. First thing you need to do here, obviously, is label all your sides, taking into account 35-degree angle over here. Label your various sides, find the rule, trigonometric rule that we use, and therefore solve for x. Put the video on pause and come back when you've finished and see if you got it right. Alright, well, my pronumeral x is actually going to be my hypotenuse, and if I look across over here, this is going to be my opposite, and obviously this therefore would be my adjacent. So what do I know? Well, I know 35 degrees. Okay, I also know my opposite is going to be 5, and I also know my hypotenuse is going to be x. So which rule actually uses opposite and hypotenuse? The rule that uses opposite and hypotenuse is the sine rule. So sine of theta equals opposite over hypotenuse. So I put in the information I know, so that would be sine of 35 equals the opposite, which is 5, over my hypotenuse, which happens to be x. Therefore x sine of 35 is equal to 5. I need x by itself, so it'll be x equals 5 over the sine of 35, and when I put that into my calculator, which is 5 divided by sine 35, I end up with x to the value of 8.72. Therefore x is equal to 8.72. Alright, well, another one for you. You need to find the value of x. We know that angle, we know that side, we know that that's 90 degrees. First thing you need to do is label the sides of your triangle, figure out which ratio we use, and then solve for x. Alright, well, first things first, this would be my hypotenuse, and opposite from where I'm looking, so that's opposite, and therefore this would be my adjacent. What do I know? I know 28 degrees. I know that my opposite is 19, and I know that I've got to find my adjacent, which is the pronumeral x. So what rule uses opposite and adjacent? And that would happen to be the tan rule. So tan of my angle equals opposite over adjacent. I put in the information I know, so I know that tan of 28 degrees equals my opposite, which is 19, and my adjacent is going to be my pronumeral x. So therefore it's going to be x tan of 28 degrees equals 19. I need x by itself, so x is equal to 19 all over the tan of 28 degrees, and when I put that into my calculator I find that the value of x is actually 35.73. So x is equal to 35.73. Alright, well here's a little bit of an extension question for you now. We know that angle, we know that side, we know this side now because you just calculated it. So what is the length of my hypotenuse? Put the video on pause and come back when you're ready and give me the answer. Alright, well there's actually two ways to find the hypotenuse. The first way is identifying the rule. And what do I know? Well, I know my angle is 28 degrees. Okay. I also know that my opposite is 19. And my hypotenuse is going to be y. Alright, so I'm going to call my hypotenuse y. So the rule that I use here is going to be sine. The sine rule is the opposite over the hypotenuse. So what do I know? I know sine of 38 degrees equals my 19 over my hypotenuse, and in this case I'm going to call it y. So y sine of 38 equals 19. I need y by itself, so y equals 19 divided by the sine of 38 degrees, and I know the sine of 38 degrees rather is 40.47. Therefore y is going to be that value. Now the second way to find the length of this side is using Pythagoras' theorem, because we've just solved for x and we know what that side is, which is 19. So using Pythagoras' theorem we can say that y squared is equal to x squared plus 19 squared. Well, 19 squared we know. Alright, so x would be 35.73, which is this over here, plus the 19 squared. And if we calculate all of that out, we end up to get 1637.904. And if we wanted to find y, obviously we'd have to do the square root of 1637.904. And if you put that into your calculator, you would end up with a value of 40.47. And look at that. They're both exactly the same. So there's two ways that we can find the third length if we know two lengths. We can either use a trigonometric ratio or we can use Pythagoras' theorem. Well, that's how we find side lengths using trigonometric ratios, or if you know two sides, how to use Pythagoras' theorem to find the third side.